Hello class, in this video we cover section 8.3, simple interest. We have two formulas to grasp and know how to apply them. The first formula is how do we calculate simple interest, I equals P times R times T. The second formula is how do we find the future value of the loan when the loan has the simple interest. Interest is the amount of money that we get paid for lending or investing money, or that we pay for borrowing money. When we deposit the money in a savings institution, the institution pays us interest for its use. When we borrow money, interest is the price we pay for the privilege of using the money until we repay it. In my table now, I have simple interest and compound interest, the comparison of the two types of important interests in the table. On the left side, we have the simple interest. Simple interest in real world normally applies to loans, your auto loan, your home loan, your student loan. Yeah, those loans, the interest of those loans are simple interest. For example, you need to borrow for convenience, let's say $100, and the annual interest rate is 5%, also for convenience. Then that means every year you would have to pay the lender $5 for the cost of the loan. Yeah, you loan $100 from your lender, and the annual interest rate is 5%. 5% times 100 is $5. So every year you owe $5. If you take the loan for 2 years, then the accumulated interest would be $10 because every year $5, every year $5. If you take the loan for 10 years, 5 times 10, that's $50, right? So by the end of the year 10, you owe the lender $100 plus $50, $150. Does that make sense? So if you need to repay the money by the end of the year 10, you have to repay $150. And the $150 is the future value of your loan. And the $100 is called the principal. In my table note, I describe principal as chicken, and I describe interest as the eggs, because chicken lay eggs, right? Yeah. So in the case of simple interest, in this case, every year the chicken lay 4 eggs. And so by the end of year 2, you have 8 eggs. By the end of year 3, you have 12 eggs. And so on. So the important thing about simple interest is the interest amount every year remains the same. And the principal also remains the same. The principal is the chicken. So for all those years, the principal remains the same, the chicken. All right? So in the example that I mentioned earlier, your principal is $100. The interest is $5 every year. It remains the same. Okay, the principal remains $100. Every year, the interest is $5. Pretty simple. That's the reason we call this type of interest the simple interest. We have an example here. The amount of money that we deposit or borrow is called the principal. Yeah, that's the definition for principal. For example, if you deposit $2,000 in a savings account, then $2,000 is the principal. The amount of interest depends on the principal, the interest rate given as a percent and varies from bank to bank, and the length of the time for which the money is deposited. So this part describes this formula. This part describes this formula. Okay? This is the simple interest formula. I equals P times R times T. Capital I here is the simple interest amount. Capital P here is the principal. Yeah, the original money you borrow or you deposit. R here is annual interest rate. Annual interest rate. It is in the format of a percent. And T here is the time in years, very important. Time in year. If you take the loan for 18 months and you need to use the formula to calculate the simple interest amount, then you do not plug in T equals 18. You're going to plug in T equals 1.5 because 18 months is 1.5 year. Yeah, T here must be time in year. All right, very, very important. I mentioned earlier, we only have two formulas for simple interest. That's the first formula. That's the first formula. I equals P times R times T. One more time. I here is the simple interest amount. P here is the principal, the original amount of money you deposit or borrow. R here has to be annual interest rate. T here is time in year. Okay, let's apply the formula to solve problems. You deposited $2,000 in a savings account at Hometown Bank, which has a rate of 1.2%. Yet even the question does not specify 1.2% is annual interest rate. It is default as annual interest rate. Okay, yeah, because it's convenient. Annually is convenient. So if it's not annual interest rate, it's a semi-annual or quarterly interest rate, monthly interest rate, the question will point it out. If it doesn't say anything, then the rate must be annual interest rate. We need to find the interest at the end of the first year. Okay. So let's organize the information we have so far. P is P is 2,000. That's the principal, right? That's the principal. R, annual interest rate, is 1.2%. Also is given. Yeah, I can just quickly convert a percent to its equivalent decimal. We have a 0.012. And we are looking for, it says the interest at the end of the first year. That means the time you keep your money in the savings account is 1 year. So it is 1. Time in year is 1. Okay. So the interest I equals P times R times T. All we need to do is to plug in the values. We plug in 2,000 principal and we multiply by annual interest rate in the format of the decimal 0.012 and then multiply by 1. And what do we have? You can use a calculator. $2,000 multiplied by 0.012 times 1 equals 24. $24. Right? Yeah, so the interest at the end of the first year is $24. Yeah, we use the simple interest formula, found the interest amount for 1 year by the end of the first year. So that's the first example. Second example is about a student loan. A student took out a simple interest loan for $1,800 for 2 years at a rate of 8% to purchase a bicycle and a laptop. What's the interest on the loan? Okay, organize the information we have. Principal is the original amount of money you borrow in this case, right? And you are taking a loan, 1800, and interest rate, annual interest rate, 8%. Convert 8% to its equivalent decimal, we have 0.08. And the T, time in year. So you take the loan for 2 years, so T equals 2. And we are looking for the simple interest generated from the loan, the cost of the loan. So I write the formula, P times R times T equals, T is 1800 multiplied by annual interest rate as a decimal, 0.08, and then multiplied by 2. Let's see, what do we have? 1800 times 2, we have 3600 times 0.08. I think I messed up the calculation. Let's do it again. So 1800 multiplied by 0.08 and then multiplied by 2. $288, because the interest rate is pretty high, 8%. Yeah, that makes sense. 144 times 2, 288. $288. That's the simple interest on the loan by the end of year 2. So if you need to pay back the money by the end of year 2, then you're gonna pay the principal 1800. On top of that, you have to pay $288 interest. So you have to pay $2,088 by the end of year 2 if you want to clear your loan, pay back your loan. Simple interest is used for many short-term loans, including automobile and consumer loans. Imagine that a short-term loan is taken for 125 days. The time of the loan is 125 over 365. Remember, when we use the formula, T must be time in year. You do not plug in T equals 125. You have to figure out how many years in 125 days. 125 divided by 365, that's the time in year. That's the year. How many years in 125 days? Because there are 365 days in a year. However, before the modern use of calculators and computers, Banks rule is very popular, prevails. They use the 360 days as the denominator instead of 365. We know if the denominator is smaller, then the fraction is bigger. So if we use 360 days instead of 365 days in the example of a short-term loan for 125 days, then the time in year is going to be bigger, even just a little bit bigger. It benefits the lender, the bank. So this is the banker's rule. With the widespread use of calculators and computers, government agencies and the Federal Reserve Bank calculate simple interest using 365 days in a year, as do many credit unions and banks. However, there are still some financial institutions they would use banker's rule because, they make the interest bigger. Remember the formula for calculating simple interest. I equals P times R times T. Yeah, principal is bigger, I is bigger. R is bigger, I is bigger. With all other things remains the same, If t is bigger, then I is bigger, right? So if you use 360 instead of 365, then the time t would be bigger, even just a little bit bigger, will make the interest amount bigger, and that benefits the bank, the lender. When a loan is repaid, the interest is added to the original principal to find the total amount due. In the problem above for the student loan, at the end of the 2 years, the student will repay, remember, $2,088, right? Is the sum of the principal and the simple interest for the 2 years. Now let's derive the second formula. The second formula is to find the future value of the loan. What is the future value of the loan? We use the capital letter A to represent the future value of the loan. Yeah, A is called the accumulated balance. In the case of you deposit the money and the bank pays you the interest, and in the future you have more, right? And A is the initial of accumulated balance. But here, when it comes to the loan, we call A the future value of the loan. Then, by comparison, P here, the principal, would be the present value of the loan. The present value of the loan. In the previous example, 1,800 is the present value of the loan. In 2 years, the value of the loan is $2,088. That is the future value in 2 years. Okay, yeah, please see the difference between P and A. Again, A is called the future value of the loan. It is the sum of the principal. It is also called the present value of the loan and the simple interest over those years. Yeah, I can derive the formula very quickly for you. I can do that on my OneNote. This section is pretty straightforward. It only involves 2 formulas. The first formula is simple interest formula, I equals P times R times T. Second formula, the future value of the loan is the sum of the principal and the interest generated over years from the loan. And if we plug in I equals P times R times T, and we have a sum of 2 terms in the expression, right? Yeah, we can write P as P times 1 and factor P out. And in the parentheses, from the first term, we have left over 1. From the second term, we have left over R times T. And this formula, A equals P times parentheses 1 plus RT, is the formula to calculating the future value of the loan for a simple interest, in the simple interest case. All right, for the simple interest case. Let's go back to the notes. Same with here, right? Same with the formula in the box. Let's apply it. Example, suppose you spend $4.95 each day, 5 days per week on specialty coffee. We're going to answer the following 2 parts. Part A, how much do you spend on this item in a year? Yeah, one at a time. Let's solve part A first. So how much you spend on this item in a year? So let's see how much you spend on the item, the luxurious coffee in a week. $4.95 a day for 5 days. That's how much you spend every week, right? Yeah, 5 days per week. How many weeks in a year? 52. Okay. Sometimes a little bit more than that, sometimes a little bit less than that. Just we use normally in general we use 52 weeks. And let's calculate the result. 4.95 multiply by 5. Oh, I messed it up. Let's do it again. Let me fix my mouse. I can use my mouse here. Okay, it's charged now. And so we have a 4.95 multiplied by 5, and then multiplied by 52. $1,287. $1,287. 1,287. Yeah, I read a book. You know how the book call those small things, like you buy a bottle of water, a bottle of like Coca-Cola and Dr. Pepper, those sugar water. Those are called latte factor. It seems like only a few dollars every day, right? But over time, it's a lot of money. For a year, if you do not spend money on that coffee, you can save almost $1,300. That could be a good trip, right? You know, the plane ticket could be the plane ticket out for a good trip. So that's how much money you spend on this item in a year. Part B. If you invested your yearly spending on gourmet coffee in a savings account with a rate of 2%, how much would you have after 1 year? Okay, so we are looking for the interest, right? Yeah, the principal is $1,287. Annual interest rate is given 2%. 2%. As decimal is 0.02. Time in year, after 1 year, it is 1, right? You might notice that in this section is about the simple interest. If the problem is about investing, depositing money in the account, the time in year always 1 year. Because in reality, savings account actually pays you compound interest. Yeah. But when the compound interest is annual compound interest, and for 1 year, it is equivalent to simple interest. That's why whenever you see a problem about simple interest, talking about depositing or investing, the time in year normally is 1 year, because in reality, loans pay simple interest, savings account pay compound interest. But you don't have to know that. In this section, so far, we only learned the simple interest concept. And the formula for calculating simple interest, I equals P times R times T equals, so we're going to plug in 1,287 multiplied by 0.02 multiplied by 1. 1 is a multiplicative identity. It doesn't contribute in multiplication. So multiply by 1 is the same with just didn't multiply anything. Let's see the result. Yeah, we have the $1,287 in the calculator already. Let's multiply that by 0.02. Oh, I messed up. Let's do it again. 1,287 times 0.02. A good calculator for this course is super important. I have stressed that more than one time, many times. Get a good calculator as earlier as possible and get familiar with it. So the I here, interest amount for 1 year, is $25.74. $25.74. Okay. Yep. So that's the how much money would you have after 1 year? Oh no, you know what? how much would you have after 1 year? And that is the future value. Okay, sorry about that. So you have to use P to plus the I. So 1287 plus 25.74. All right. So sometimes even you only remember the first formula. You don't really have to remember the second formula because you can derive the formula for the future value of the loan on your own. Yeah, the future value simply is the sum of the principal and your interest. You could always find the interest first and then add the interest on top of the principal. Yeah, so we add that to $1,287. 1312.74 dollars, 24 cents. Yeah, that's how much money you would have after 1 year. Yeah, be very careful. Be very careful. Be clear what is the question asking. In this case, we are not looking for part B. We are not looking for interest. We are looking for future value. If you invest your yearly spending on gourmet coffee in a savings account with a rate of 2%, how much would you have after 1 year? You would have more than $1,300. Okay. Next example. In order to start a small business, a student takes out a simple interest loan for $4,000. That's the principal. For 9 months, that's the time, at a rate of 8.25%. That's the annual interest rate. Part A, how much interest must the student pay? Okay, P equals 4,000. R equals 8.25%. Convert 8.25% to its equivalent decimal. We have a 0.0825. T is, yeah, please, T is not 9 months. T is not 9. Yeah, it is 9 months, but you do not assign the value of T as 9. Instead, it's 9 over 12. Okay, 9 over 12. Yeah, because we have 12 months in a year. 9 months is 3/4 actually. Is 3 over 4 or 0.75. Yeah. I would do the decimal because you have a calculator. Calculator handle decimals very very well. So 9 months is 3/4 of a year. 3/4 of a year. And that is 0.75 a year. And formula for finding the interest, I equals P times R times T equals P is 4,000 multiplied by annual interest rate 0.0825, 0.0825, and multiplied by time in year 0.75, 0.75 equals. Okay, let's do the calculation. 4,000, 1, 2, 3, times 0.0825, and then times 0.75 equals 247.5. 247.5. $247.50. That's the interest for 9 months. That's a lot. Yeah, because the interest is so high. Yeah, interest is very high. Part B, find the future value of the loan. Yeah, you do not have to memorize the second formula for future value. I don't really do that. All I remember is the first formula for finding the simple interest, and know future value of the loan simply is the sum of the principal and the interest. So part B, we are looking for the future value of the loan. A, and it is the sum of the principal and the interest. The principal is 4,000 and the interest is 247. We got it from part 1, part A. And add them together is $4,247.50. All right? Future value of the loan. Taking a loan is pricey. But that's the cost that you could start your business, right? One of the costs. The next part in this guided note says the formula for future value has 4 variables. If we are given values for any 3 of them, then we can solve the 4th variable. Let's look at this example. That's the last example. You borrow $5,000 from a friend and promise to pay back $6,800 in 2 years. What simple interest rate will you pay? Okay, so we have more than one way to handle the problem. Depends on how much you remember. Yeah, do you remember all the formulas, or you only remember the most basic formulas? Let's organize the information we have. So first, you borrow $5,000. That is the principal. And you plan to repay, you promise to repay the friend $6,800. $6,800. And what is that? What is $6,800? Is your future value, is the future value of the loan, right? For 2 years, so T equals, I have a comma here. For 2 years, so T equals 2. And we are looking for R, right? We are looking for R. In the case that you remember the formula, what formula? A equals P times parentheses 1 plus R times T. In the case you remember that formula, you can plug in the values for 3 of the 4 variables. So A is 6,800. T is 5,000. In the parentheses, you have 1 plus R. R is unknown, so R is the only variable. We don't have the value yet. Just leave R as R. T is 2, so 2R. 2R. And we are going to solve this equation for R. Okay? So firstly, allow me to use write this to solve it. It's going to be easier. So firstly, I'm going to switch the order of the 2 sides of the equation. 5,000 times 1 plus 2R equals 6,800. When you solve an equation, draw an imaginary line in the middle. Whatever to the left is the left side, whatever to the right is the right side. So let's peel the onion. Solving an equation like a peel an onion. Imagine your unknown is hidden in the center of the onion. You are get rid of the skin one layer after another and eventually expose the unknown variable in the center. So when you peel an onion, you peel the outside skin first, and then you can reach the inner layer, right? Same with here. We are going to peel the 5,000 off. We divide each side by 5,000. And we have 1 plus 2r equals 6,800 over 50. Yeah, let's see what is 6,800 over 50. 5,000, but 5,800. 6,800 divided by 5,000. 1.36. 1.36. Right? And then we are going to peel the 1 off, get rid of the 1. We minus 1 from each side, right? And then we have 2r equals 0.36. And then we get rid of the coefficient of r, divide by 2, divide by 2, divide by 2. We have r equals 0.18. 0.18. So your interest rate, your simple interest rate is going to be 18%. That is very, very high. That is very, very high. Okay? And in the case that you do not remember this formula, do we have a way to solve the problem? I think so. I think so. Because the future value of the loan is given. The principal of the loan is given, right? Then what we can do? I'm going to use a different color to figure that out. I'm going to use a blue color. Can I do this? Change this to blue. So your interest amount, simple interest amount, is the difference between the future value of the loan and your principal, right? Yeah, your principal is $5,000. Your future value of the loan is $6,800. What's the difference between them? 6,800 minus 5,000. That is $1,800, right? $1,800. That's your interest rate. That's your interest amount. And you need to, even you do not remember this formula, but you need to remember the simple interest formula. I equals P times R times T. Okay? And now you can plug it in. I is 1,800. P is 5,000. T is 2. R is unknown. So we have 1,800 equals 5,000 times 2. That is 10,000. And divide each side by 10,000. 1, 2, 3. 10,000. And we have R equals 1,800 over 100,000. Yeah. And you get rid of 2 zeros here, get rid of 2 zeros here. Then R equals 18 over 100. Remember, what is percent mean? Percent means divided by 100, right? So 18 divided by 100 is 18%. You got the same value. So be flexible. Be flexible. The most important, this section, is this formula. Simple interest formula. This one. For the future value of the loan formula, if you want to remember it, is good. Of course, it's good. If you don't remember it, it's totally fine. But you need to know the future value A is the sum of the principal and your interest. And also, you need to have a certain algebra foundation in order to do the assignment for this section. When we have the formula and we plug it in, and we trying to solve for the unknown, we are basically solving an equation. You need to know how to evaluate the expression and solve the equation. That's the very basic thing. All right, guys. So that's everything for today. Yeah, simple interest. I'll see you next time, next video. We are going to talk about compound interest. Compound interest is more interesting. Yeah. You can look at my table note, the comparison of simple interest and the compound interest to see the difference. Okay, I'll see you next video.